Hello viewers, in today's session we are going to discuss another very important problem from definite integrals, and in this session we are going to find out the value of this integral that is from minus half to 0, and we have secant inverse of 1 over x plus 1 dx, right? So we'll see how we can evaluate this integral using two important concepts. The first one is integration by substitution method, and then applying the method of integration by parts, right? So let us first apply the method of substitution to simplify this integrand, and then apply the method of parts. So let us first substitute, say t is equal to secant inverse 1 over x plus 1. So we'll start with this substitution. So now we can write secant t is equal to 1 over x plus 1, right? So secant t is equal to 1 over x plus 1. So let us differentiate both sides with respect to t. So we can now write d by dt of secant t, and here we have d by dt of 1 over x plus 1, right? Now the derivative of secant t is secant t tan t, and here we have d by dx of 1 over x plus 1, and then we can write dx over dt. So by chain rule we have written d by dx of 1 over x plus 1 and then dx over dt. So we can now write secant t tan t, and the derivative of 1 over x plus 1 is minus 1 over x plus 1 square, and here we have dx over dt, right? Now see, 1 over x plus 1 is equal to secant t. So if we square both sides, then we have secant square t is equal to 1 over x plus 1 square. So substituting 1 over x plus 1 square as secant square t, we have secant t tan t, and here we have minus secant square t dx over dt. So now we can write secant t tan t, and we can take minus secant square t to the denominator here, and here we have dt, and here we can write dx. Now this secant t and this secant t get cancelled, so we have dx is equal to tan t dt, and in the denominator we have minus secant t. Now tan t can be written as sine t over cos of t, and here for secant t we can write 1 over cosine t, and here we have dt. Now cos t and cos t get cancelled, so we are left with minus sine t dt, right? So dx can be written as the negative of sine t dt. Okay, so now let us change the limits accordingly. So here we see that the limits of integration vary from x is equal to minus half to x is equal to 0. So when x is equal to half, then secant t is given by 1 over minus half plus 1. So this is 1 over minus half plus 1 is half. So this is 2, right? So secant t is equal to 2. So t is equal to pi by 3, because secant pi by 3 is equal to 2, right? Okay. Now when x is equal to 0, then secant t is equal to, here we'll take x is equal to 0. So we have 1 over 0 plus 1, that is equal to 1. So secant t is equal to t. So it implies that t is equal to 0 because secant 0 is equal to 1, right? So when x varies from minus half to 0, then t goes from 0 to from pi by 3 to 0. So now let us take this integral as I. So I can be written as pi by 3 to 0, and then secant inverse 1 over x plus 1 is t. So here we can write t, and for dx we can write minus sine t dt. So now we have to evaluate this integral. So we can now write pi by 3 to 0, and here we have minus t sine t dt, and we can see that the integrand is the product of two functions. This is a polynomial function t, and this is a trigonometric function. So to evaluate this integral, we'll make use of integration by parts, and the formula for integration by parts is given by integral u dv is equal to uv minus here we have v du, right? So if we can write this integral as pi by 3 to 0, we can write t, and minus sine t dt can be written as d of cosine t, right? The derivative of cosine t. So if we compare t d cos t with this one, then t is our u and v is our cosine t, right? So we have u is equal to t and dv is equal to d cos of t, right? So now we have the formula uv minus integral v du. So uv is t cos t, then we have integral v du, and v is given by cosine of t, and du is given by dt, and the limits of integration are from pi by 3 to 0, right? So we have t cos t minus integral cosine t is simply sine t, and the limits of integration are from pi by 3 to 0. So now let us substitute the limits and taking the difference. So first we'll take t is equal to 0. So here when we take t is equal to 0, this quantity is 0, and then sine of 0 is also 0, right? And then we take pi by 3. So here we have pi by 3 cos pi by 3 minus sine of pi by 3. So here we have minus pi by 3, and cos pi by 3 is given by half, and then we have sine pi by 3, that is square root of 3 over 2. So now we can write it as root 3 over 2 minus pi by 6. Now taking the LCM, we have 6, and then we have 3 root 3 minus pi, right? So the value of this integral is given by 3 root 3 minus pi over 6. So this is how by making use of two important techniques of integration. The first one is integration by parts, and then the second is integration by substitution. We can easily solve these kind of integrals. Hello viewers, In today's session, we are going to discuss another important problem from integrals, right? So here in this class, we are going to evaluate this integral that is from 0 to 1 cot inverse 2 over x plus 1 dx, right? So here we have to find out the value of this definite integral from 0 to 1, right? So here to evaluate this important integral, we'll make use of the method of integration by substitution, and then we'll apply the method of integration by parts. So let us start. So let us call this integral as I, right? So here we'll first find out the indefinite integral, that is integral cot inverse 2 over x plus 1, and then we can easily find out the definite integral by substituting the limits and taking the difference, right? So let us take the indefinite integral as I1, so that our integral I is I1 from the limits that is 0 to 1. So here we have dx. So let us make this substitution, that is theta is equal to cot inverse 2 over x plus 1, right? So theta is equal to cot inverse 2 over x plus 1. So we can now write cot theta, taking cot inverse to the left hand side. So we have 2 over x plus 1, right? So let us find the value of x in terms of theta. So we can now write x plus 1 is equal to 2 over cot theta, right? And we know that 1 over cot theta is tan theta. So we can write x plus 1 is equal to 2 tan theta. So now we have x is equal to 2 tan theta minus 1. So this is the value of x in terms of theta. Now let us differentiate x with respect to theta. So we have dx over d theta is equal to d by d theta of 2 tan theta minus 1. So here we have 2. The derivative of tan theta is secant square theta, and 1 is constant, so the derivative of 1 is 0. So we have 2 sec square theta. So dx over d theta is equal to 2 times secant square theta. So we can now write dx is equal to 2 secant square theta and d theta. So let us now express this integral I1 in terms of theta. So we have cot inverse 2 over x plus 1. For cot inverse 2 over x plus 1, we can write theta, and then for dx, we can write 2 secant square theta d theta. Now 2 is a constant, we can take it outside the integral sign. So we have theta secant square theta d theta. So now we have to evaluate this integral, which is the product of two functions, that is theta and secant square theta. Now theta is a polynomial function, and secant square theta is a trigonometric function, right? And we can write d of tan theta, that is the derivative of tan theta, as secant square theta d theta, right? So we can replace secant square theta d theta by the derivative of tan theta. So we can now write I1 is equal to 2 times theta, and here we can write d of tan theta, so that we can apply the method of integration by parts. So integration by parts formula says that if we have two functions u and v, which are functions of say theta, then u dv is given by uv, that is the product of u and v, and then we have v du, right? So this is the formula for integration by parts. So here we can take theta as u and v as tangent of theta, right? So now I1 can be written as 2 times here we have u times v, so u is theta and v is tan theta minus integral v du. Now v is tan theta and u is theta, that is d theta. So now we have 2 times, here we have theta tan theta minus integral of tan theta is equal to a negative of log of cosine theta, right? We can also write the integral of tan theta d theta as a log of secant theta. So we'll use this result. So here we have minus a log of cos theta. So now I1 is given by 2, and here we have theta tan theta, and then minus times minus is plus, so we have log of cos theta, and obviously the constant of integration as c. So now I1 is given by 2 times theta tan theta, then we have 2 log of cos theta and plus c, right? Now see the indefinite integral of cot inverse 2 over x plus 1 is given in the terms of theta. So now we have to convert this result or this expression in terms of theta, right? So we have assumed that cot of theta is equal to 2 over x plus 1, right? So if we take the reciprocal, then here we have 1, so 1 over cot theta is equal to x plus 1 over 2, and 1 over cot theta is tangent of theta. So tan theta can be replaced by x plus 1 over 2, right? Now see, here we have cot theta is equal to 2 over x plus 1. So let us make a right angle triangle here, and here we can take theta, and we know that cot theta is base over that is perpendicular, right? So here we have base and here we have the perpendicular. So base can be taken as 2 and the perpendicular as x plus 1. So applying the Pythagoras theorem here, we can write the value of the hypotenuse as square root of BC square plus AB square. So we have square root of 2 square plus x plus 1 square, and we can write 4. 2 square is 4, then a plus b whole square, this is x square plus 2x plus 1. So we have square root of x square plus 2x plus 5. So the length of the hypotenuse, that is AC, is square root of x square plus 2x plus 5. So here we can write x square plus 2x plus 5. So now I1 can be written as 2, and then we have theta. Now theta is cot inverse 2 over x plus 1, and then we have tan theta. So tan theta is x plus 1 over 2, right? So now we are converting this expression in terms of x, and here we have 2 times the log of cosine theta, and to get the value of cos theta in terms of x, we can make use of this right angled triangle. So cosine theta is given by base over hypotenuse, right? So the base is 2 and the hypotenuse is square root of x square plus 2x plus 5, right? So we can take this square root term to the numerator. We can write x square plus 2x plus 5 raised to minus half. So here we can write 2 times x square plus 2x plus 5 raised to minus half, and c is our constant of integration. So let us simplify this expression. So here this 2 and this 2 get cancelled. So we have I1 is equal to x plus 1. Then we have cot inverse 2 over x plus 1. And then here we have 2, and see here we have the product of two numbers. 2 times x square plus 2x plus 5 raised to minus half. So here we can apply the property of log, that is log mn, that is product of m and n is given by log of m plus log of n. So here m can be taken as 2 and n can be taken as this term. So we have log of 2, and then we have plus log of x square plus 2x plus 5 raised to minus half, and c is the constant of integration. So here we have x plus 1, then cot inverse 2 over x plus 1, and then we can multiply these two terms by this 2. So we have 2 log 2 plus 2 times log of this term. So we can now take this minus half in front of log. So we have minus half, and then we have log of x square plus 2x plus 5, and c is the constant of integration. So here we have used this property of log, that is log m raised to n is n log m. So now we can cancel this 2 and this 2, and we have I1 is equal to x plus 1. Then we have cot inverse 2 over x plus 1. And now see here we have 2 log 2. Which is a number that is a constant, and here we have c as the constant of integration. So we can merge these two quantities, that is 2 log 2 plus c, and we can call this expression as some other constant. Let us say that constant is k, right? And here 2 and 2 get cancelled, so we have minus log of x square plus 2x plus 5, and k is our new constant of integration. So viewers, the indefinite integral of this function, that is cot inverse 2 over x plus 1 with respect to x, is given by this expression, that is x plus 1 cot inverse 2 over x plus 1 minus log of x square plus 2x plus 5 plus k, where k is the constant of integration. So now we have to find out the definite integral from 0 to 1. So what we will do, we'll simply utilize the limits and we'll take the difference. And when we find out the definite integral, will not consider this constant of integration. So now I can be given by this expression from x is equal to 0 to 1. So first we'll take x is equal to 1. We can now write 1 plus 1 is 2. Then we have cot inverse 2 over 1 plus 1 is 2. And then we have minus log of 1 square, then we have 2 times 1 plus 5. So this is our first term when we take x is equal to 1, and then I will take x is equal to 0. So here we have 0 plus 1 is simply 1. Then we have cot inverse 2 over 0 plus 1 is 1, right? And then we have minus log, and here 0, that is 0 square is 0, 2 times 0 is 0, so we are simply left with 5 only. So we can now solve this expression. We have 2, 2 and 2 get cancelled, so we have cot inverse of 1 minus log of this is 5 plus 2 7 plus 1 8, right? And then we have minus, here we have simply cot inverse of 2, and then we have minus log of 5. So this is 2 cot inverse 1 minus log of 8. Then we have minus cot inverse 2, and this is plus log of 5. So 2 cot inverse 1 minus cot inverse 2. Cot inverse 1 is pi by 4. So cot inverse 1 can be written as pi by 4 because cot pi by 4 is equal to 1. So here we have 2 times pi by 4, and then we have minus cot inverse 2, and we can combine these two terms, that is the log 5 minus log of 8, which can be written as log of 5 over 8. So here we have log of 5 over 8. Now this is 2 times 2 is 4. So we have pi by 2 minus cot inverse of 2. And here we have log of 5 over 8. So now pi by 2 minus cot inverse 2 can be replaced by tan inverse of 2, because see, we know that tan inverse x plus cot inverse x is equal to pi by 2. So if we replace x by 2, because this is an important identity in inverse trigonometric functions. So tan inverse x plus cot inverse x is equal to pi by 2 for all values of x belonging to the set of real numbers, right? So when we take x is equal to 2, we have tan inverse 2 plus cot inverse 2 is equal to pi by 2. So taking cot inverse 2 to this side, we have tan inverse 2 is equal to pi by 2 minus cot inverse 2. So replacing pi by 2 minus cot inverse 2 by tan inverse 2, and here we have log of 5 over 8, right? So this is the value of this integral I, that is 0 to 1 cot inverse 2 over x plus 1 dx, and the value of this integral is given by tan inverse 2 plus log 5 over 8. So this is how we can evaluate the indefinite integral and the definite integral.